Okay, in this video we are going to solve logarithmic equations, and we're going to kind of do the opposite of what we do with exponential equations, in that we're going to end up using an exponent. We're going to rewrite the equation as in its exponent form in order to solve for the variable. So, got some steps listed here. First of all, we do want to get a single log on one side, and we may have to use log properties to get that done. And then once we have that, again, rewrite it in exponential form, and then we should be able to solve. So again, what I want you to keep in mind every time is that the log base a of x equals y means that a to the power y equals x. You need to know this in order to rewrite those. So what we have is log base 2 of x plus 2 equals 5. The first thing I'm going to do is I'm going to rewrite this because I have a single logarithm on this side. What I'm going to do is take the stuff on the inside of the log, which is x plus 2, and I'm going to set that equal to, it's the base, which is 2, to the exponent of 5. Log base 2 of x plus 2 equals 5 means x plus 2 is equal to 2 to the 5th power. And then at that point in time, I'm just going to evaluate 2 to the 5th, which is 32, subtract 2, and we get that x is equal to 30. Natural log of x equals 8. Remember, natural log is log base e. So all I have to do here is say that the stuff on the inside, understanding that my base here is e, means that I have x equals e to the power 8. You could use a calculator to evaluate e to the 8th. I'm just going to leave that as e to the 8th. It's more accurate than any decimal I could give you. Moving on, we have 4 plus 3 log of 2x equals 16. So again, the first thing I'm going to do is isolate it so I just have a single log on the left side. First, you cannot add the 4 and the 3 together because the 3 is multiplied here, so I can't do addition before I do multiplication. So what I have to do is actually just subtract the 4 first. So we have 3 log of 2x is equal to 12. Then I'm going to divide by 3 in order to get rid of that 3 out front. And I'm going to have log of 2x is equal to 4. And now I can rewrite, because I've isolated the log. Do know that if the base is not written there, remember it is an understood base 10. So I'm going to take the stuff on the inside, which is 2x, and that's going to equal the base to the exponent that's on this side. So 2x equals 10 to the power 4. 10 to the power 4. So 10 squared is 100, 10 to the 3rd would be 1,000, 10 to the 4th is going to be 10,000, and then we're going to divide that by 2, and x is going to equal 5,000. And then we have our last one here, log of x plus 2 plus log of x minus 1 is equal to 1. So I have two different logs on the left side. When you have more than one log written on one side, your goal here is to use the laws of logarithms in order to condense this down into a single log so that we can then rewrite it. So the first thing I'm going to do is I know that if we're adding two logs, I can combine this as a single log by simply multiplying the stuff together on the inside. So I can write this as a single log by taking x plus 2 and multiplying by x minus 1 on the inside of that one log. I'm going to go ahead and do that. So if I multiply the inside here, I need to multiply this out. I'm going to get x squared minus 1x plus 2x, so it's going to be plus 1x and minus 2, and that's going to equal 1. At that point in time, again, I'm going to realize this is log base 10. So I'm going to take the stuff on the inside, which is x squared plus x minus 2, and I'm going to set that equal to 10 to the first power, which is just 10. So because this is quadratic, I'm going to subtract the 10 to get this equal to 0. So we have x squared plus x minus 12 equals 0. This factors x plus 4 and x minus 3 equals 0, which means we get x equals negative 4 and x equals 3. Now you do need to be careful here. Go back to your original equation. Remember that with logarithms, the domain is usually 0 to infinity, but the idea is that you can't have 0 or any negative number inside of your log. So if we were to plug these numbers in, I haven't checked the other ones yet because they've been fine, but if I were to plug in negative 4 or positive 3 for x, would I get a negative number or 0 inside of my log? And with negative 4, the answer is yes. So I cannot say that x equals negative 4. It makes the inside of each one of these logs a negative number, so that does not work. But 3 is an okay answer. 3 would not give me a negative inside the log. Okay, so condense to one side so that you just have a single log on one side, rewrite it in its exponent form, and then you should have an equation that should be fairly easy to solve.